Hello, in this video we're looking at MEI FP1, the May 2010 paper question 6, which is on proof by induction. We're given a sequence defined by its first term and an inductive definition. We're asked to calculate U3, which is to make sure that we have read the question properly, and then to prove a result by induction. So we must make sure that we use that method, otherwise we won't get all of the marks. So first of all, calculating U3, where we know that U1 is equal to 2, U2 is equal to U1 over 1 plus U1, so that's 2 over 1 plus 2, which is 2/3, and U3 is equal to U2 over 1 plus U2, so that's 2/3 over 1 plus 2/3, which is 2/3 divided by 5/3, 2/3 times 3/5, which is 2/5. Then the proof by induction. Make sure you take this carefully step by step and don't cut any corners. So the first thing to do is to consider when n equals 1. Our result there, 2 over 2 times 1 minus 1, is 2 over 1, which is 2, which is equal to the given value for U1. So the result is true for n equals 1. We then assume the result is true for n equals k. In other words, that UK is equal to 2 over 2k minus 1. Then, using the inductive definition, we know that UK plus 1 is equal to UK over 1 plus UK, which is 2 over 2k plus 1, 2k minus 1, divided by 1 plus 2 over 2k minus 1. That's 2 over 2k minus 1 divided by, putting that over a common denominator, 2k minus 1 plus 2 over 2k minus 1. That's 2 over 2k minus 1 multiplied by, turn that upside down, 2k minus 1 over 2k plus 1, which is cancelling 2 over 2k plus 1. And that's 2 over 2 lots of k plus 1, take away 1. But that is the required result for n equals k plus 1. So I can now start writing my conclusion. But this is the required result for n equals k plus 1. Therefore, if it is true for n equals k, then it is also true for n equals k plus 1. Since it is true for k equals 1, for n equals 1, sorry, since it is true for n equals 1, it is true for all positive integers n. Let's have a look at the mark scheme for this question. It's really important that you understand exactly what you're given marks for in this sort of question. The first bit is reasonably straightforward. There's a method mark for using the inductive definition and an accuracy mark for getting the correct answer. For the proof by induction, as always, there's a single mark for all of the bit dealing with the case n equals 1. There's an explanation mark for that statement there. This bit here doesn't have a mark, but you're advised to write that down, so you're translating the statement into algebra. There's then a method mark for attempting UK plus 1 and an accuracy mark for getting down to a simplified answer. We've then got an explanation mark for those statements there, and those are dependent on the accuracy mark previously and the explanation mark also previously about assuming the result is true for n equals k. And there's a final mark which is dependent on the B1 at the beginning for dealing with the case n equals 1 and the previous explanation mark, and therefore what that's dependent on as well. If you want to find videos of other questions on this unit or on other units, please visit the Further Maths Support Programme's website. Goodbye.